Hi, it is Cleophas from On My Space Tutors. In this video, we are going to look at equations of tangents and normals to a curve. First of all, we shall look at how to obtain the equation of a tangent to a curve. So supposing you have been given this curve shown here, and then we have a tangent which is touching the curve at point xy. Then to determine the equation of the tangent, which is basically a straight line, we shall first of all determine the gradient of the curve. So the gradient of the curve at point xy is also equivalent to the gradient of the tangent at point xy. Example. So we have been asked in example 1 to find the equation of a tangent to the curve y is equals to 3x cubic plus 2x squared plus 10 at point 2, 42. So the first step is to look for the gradient function. That is, we shall take the derivative of y with respect to x. So if we apply the power rule, then this means 3 by 3, which will give us 9. The power, reduce it by 1, I'll have it as x squared. Then plus 2 by 2 will give us 4. Reduce it the power by 1, we will remain with x raised to power 1. And then the differentiation of our constant, in this case 10, will give us a 0. Once you obtain the gradient function, to obtain the gradient of the curve at point x is equals to 2, then it means that we shall go ahead and substitute into the gradient function the value of x as 2. So therefore, this means that dy dx will be equals to 9 multiplied by x squared. In this case, x is 2. So this will be 2 squared plus 4 multiplied by 2. So this means 9 multiplied by 4 to give us 36 plus 4 by 2 to give us 8. So 36 plus 8 will give us 44. So we note that the gradient of the curve is also equivalent to the gradient of the tangent. So we have already obtained the gradient of the curve as 44. So the gradient of the tangent will also be 44. So which means that we have for the tangent the gradient as 44. It's important to note that the gradient of the tangent is 44 and that the tangent is a straight line. So it's a straight line which is also passing through point 2 and 42. So to obtain the equation of the tangent, we shall also say that it passes through another point with coordinates xy. Therefore, we know that the gradient of a straight line is given by change in y over change in x. So this should give us a gradient of 44. So which means that next we are going to take change in y, which will be y minus the corresponding y coordinate, which is y minus 42, divided by x minus the corresponding x coordinate, which is x minus 2, which will give us a gradient of 44. We shall go ahead and simplify. So we have y minus 42 divided by x minus 2 should give us a gradient of 44. So we shall put this over 1 and we cross multiply. That is 1 multiplied by y minus 42 is equals to 44 multiplied by x minus 2. 1 by y gives us y. 1 by 42 gives us 42. 42 by x gives us 42x. And 42 by 2 gives us 88. So we shall take negative 42 to the other side of the equation, where it will become positive. So we will have 44x minus 88 plus 42. And if we collect the like terms, this will mean minus 88 plus 42 will give us minus 46. So the equation of the tangent at point 2, 42, the equation of the tangent is given by y is equals to 44x minus 46. In our second example, we have been asked to find the equation of the tangent to the curve y is equals to x cubic minus 4x squared minus 1 at x is equals to 1. First, we shall obtain the gradient function. That is, we shall take the derivative of y with respect to x. Applying the power rule, we shall have 3 multiplied by 1 give us 3, and then the power reduced by 1 shall have x squared minus 2 by 4 gives us 8, reduce the power by 1, we have it as x. And then if we differentiate negative 1, it being a constant will give us 0. So we shall go ahead and obtain the gradient of the curve at point x is equals to 1. We do this by simply substituting the value of x in the gradient function with 1. So this is 3 multiplied by 1 squared minus 8 multiplied by 1. So this is 3 minus 8, which will give us negative 5. So we note that the gradient of the curve is equals to the gradient of the tangent. So we have obtained the gradient of the curve as negative 5. The gradient of the tangent will also be equals to negative 5. So the information we have about the tangent is that its corresponding gradient is negative 5 and it passes through point x is equals to 1. So to completely define this point, we shall need to obtain the corresponding y coordinate. To do that, we shall substitute the value of x into this equation. We shall substitute x is equals to 1. So if the y is given by x cubic minus 4x squared and then minus 1, to obtain the y coordinate when x is equals to 1, substitute x with 1. So this is 1 cubic minus 4 into 1 squared minus 1. So this is 1 minus 4 minus 1, which will give us negative 4. Therefore, our gradient is negative 4 and the tangent passes through point 1, negative 4. We already know that the gradient is negative 5 and that the tangent passes through point 1, negative 4. So to obtain its equation, we shall say it also passes through another point defined by x and y. So we shall say that the gradient of a straight line is given by change in y over change in x, which will give us a gradient of negative 5. So we shall take y minus the corresponding y coordinate, which will be y minus negative 4 divided by x minus the corresponding x coordinate, which is 1, which will give us a gradient of negative 5. So two negatives multiplied give us a positive. So we shall have y plus 4 over x minus 1 to be equals to negative 5. We can put negative 5 over 1 and we apply cross multiplication. So this means y 1 into y plus 4 minus negative 5, negative 5 into x minus 1. So 1 by y gives us y, 1 by 4 gives us 4, negative 5 by x, negative 5x, negative 5 by 1 gives us positive 5. So if positive 4 crosses equal sign, it becomes negative. So we shall have y is equals to minus 5x plus 5 minus 4. So this is gives you y minus 5x. So plus 5 minus 4 will give you plus 1. So the equation of the tangent is given by y is equals to 5 negative 5x plus 1. Next, we look at how to obtain the equation of a normal to a curve. So take note that in this case, you have your curve and there is a tangent which is touching the curve at point xy. So we have a normal. Now the normal is actually perpendicular to the tangent. So once you obtain the gradient function of the curve, you can obtain the corresponding gradient of the curve at this given point. We have already noted that the gradient of the curve at this point xy is also equivalent to the gradient of the tangent. But given that the normal is perpendicular to the tangent, then the product of the gradient of the normal and the gradient of the tangent should give us -1. So we shall take an example. Take example 1, which provides that we find the equation of a normal to a curve whose equation is given by y is equals to 2x cubic minus x squared plus 10 at point 111. So first, we obtain the gradient function by taking derivatives of y with respect to x, and we apply the power rule. 3 by 2 gives me 6. I reduce the power by 1. I'll have x squared minus 2 by 1 gives me 2. I reduce the power by 1. I'll have minus 2x. So at point x is equals to 1, according to the coordinates we have been given, the gradient of the curve will be given by substituting the value of x in the gradient function by 1. So this is 6 multiplied by 1 squared minus 2 multiplied by 1. So this gives me 6 minus 2, which will give me 4. And we note that the gradient of the curve is equivalent to the gradient of the tangent. So we have the gradient as 4 for the curve and also 4 for the tangent. But we are looking for the equation of the normal to the curve. We have noted that the normal is perpendicular to the tangent. So we know that the normal is perpendicular to the tangent. So given that the gradient of the tangent is 4, can say this is 4. We are looking for the gradient of the normal, which we don't know. But we know that we can call this one m1, can call this m2. So m1 multiplied by m2 should give us -1. So where m1 is the gradient of the normal. So m1 multiplied by m2, which is 4, should give us -1. So if we simplify this, this will be 4 m1 is equals to -1, and m1, if we divide both sides by 4, it will give you -1 divided by 4. So the gradient of the normal. So for the normal, the gradient is equivalent to -4, and we know that it passes through point 111. So to obtain the equation of the normal, we shall say that it also passes through a point defined by xy, by x and y. So we know that for a straight line, which the normal is, the gradient is given by change in y over change in x. So this should give us a gradient of -1/4. So which means that I take y minus the corresponding coordinate, which is y minus 11, divided by x minus the corresponding coordinate, which is 1. So x minus 1. So it should give us a gradient of -1/4. So the next step is that we shall cross multiply. That is 4 multiplied by y minus 11 is equals to -1 multiplied by x minus 1. So 4 by y gives us 4y. 4 by 11 gives us 44. Then -1 by x gives us -x. -1 by -1 gives us +1. So we have 4y. We move -44 to the other side of the equation. It becomes positive. We have minus x plus 1 plus 44. So which will give us 4y is equals to minus x plus 45. So we have 4y is equals to minus x plus 45. To express it in the form y is equals to mx plus c, we can divide both sides by 4, by 4, by 4, which will give us y is equals to minus x over 4 plus 45 divided by 4 as the equation of the normal to the curve. Example 2, we are required to find the equation of a normal to the curve y is equals to x cubic plus 2x squared minus 3 at x equals to -1. So first, we obtain the gradient function of y by taking derivatives of y with respect to x and applying the power rule. 3 by 1 gives us 3, and then we reduce the power by 1, so we have 3x squared. The next term, 2 by 2, gives us 4, and then reduce the power by 1, you end up with 4x. And -3 is a constant. If we differentiate it, we get a 0. So we note that at point x is equals to -1, then the gradient function, which is given by 3x squared plus 4x, will be used to obtain the gradient of the curve by substituting the value of x with -1. So this is 3 into -1 squared plus 4 into -1. So -1 squared gives you +1 multiplied by 3 to give us 3. 4 multiplied by -1 gives us -4. So 3 minus 4 gives us -1. We note that this is the gradient of the curve. We note that this is the gradient of the curve and is also equivalent to the gradient of the tangent. So this is equivalent to the gradient of the tangent. So -1 for the gradient of the curve, which is also equivalent to the gradient of the tangent. So we have noted that the tangent and the normal are perpendicular. So in this question, we need the equation of the normal. So we know that the normal is perpendicular to the tangent. So say that if the gradient of the tangent as given in this problem is -1, so let us say this is M2, we are looking for M1, which is the gradient for the normal. We note that for perpendicular lines, if we multiply their gradients, we get -1. So M1 we don't know, M2 we know as -1 should give us -1. So which means this is -M1 is equals to -1. We divide both sides by -1, we shall have M1 being as equivalent to +1. So we already have that for the normal, the gradient is +1. And the normal goes through a point whose x coordinate is defined by -1. So we need to obtain the corresponding y coordinate, which we shall do so by substituting into the equation of y, which is given by x cubic plus 2x squared minus 3. So if we substitute x with -1, we shall have -1 cubic plus 2 into -1 squared minus 3. So if we simplify this, we have -1 cubic, which is -1, plus 2 multiplied by -1 squared. So -1 squared is +1, multiplied by 2 we get 2, then minus 3. So -1 plus 2 minus 3 should give us -2. Therefore, we have the gradient as +1 and the coordinates as -1, -2. So we have our tangent, which is a straight line with a gradient of +1 passing through point -1, -2, and also we say it passes through a point xy. So we say that the gradient of a straight line is given by change in y over change in x. So in this case, it should give us a gradient of 1. So the 2 points we have are -1, -2, and another point xy. So we take change in y, which will be given by y. This is the coordinate of y minus the corresponding coordinate of y. So minus -2 divided by the x coordinate minus the corresponding x coordinate, which is -1, should give us +1. So this we shall have -1, negative, and a negative, giving us a positive. Y plus 2 divided by x plus 1 should give us +1. So we can put 1 over 1 and then we cross multiply. So 1 multiplied by y plus 2 is equals to 1 multiplied by x plus 1. So 1 by y gives us y, 1 by 2 gives us 2, 1 by x gives us x, 1 by 1 gives us 1. So we take positive 2 to the other side of the equation, becomes negative. So we have y is equals to x plus 1 minus 2, which we end up with y is equals to x minus 1 as the equation of the normal to the curve.